go through a demonstration about assembly files and some of the assembly constraints that you can use in those files. So the first thing I'm going to do is open up my assembly practice files, and I'm going to find the base. I'm going to go ahead and open that. I'm going to place the base right into my assembly file, and I'll hit escape because I only want to place one of those in here. One thing that I want you guys to see is that the base can move around. It's not actually grounded in this assembly file. If I wanted to make this base grounded so it didn't have any degrees of freedom, I could right click on it and click ground, and notice how it puts a pin. That means that that part is grounded. So sometimes it's nice if you have a base component, the first component you put into an assembly file, to actually make it grounded. The next thing that I'm going to do is go ahead and place the next component. So I'll find again my assembly practice files. I'm going to put in 2 of the cubes. So I'll place 2 of those cubes in, and then the last one I'll put in one cylinder. Actually, I'm going to go ahead and place 2 cylinders, and we'll do a couple of things with cylinders. So again, you can see over here in my browser that the base is grounded and these other components can be moved. They have 6 degrees of freedom. And so when we constrain things, we want to get rid of those degrees of freedom. So I'm going to go ahead and click Constrain. I'm going to come over here to my cube, and I'm going to choose 2 surfaces. I'm going to mate those 2 surfaces together. And so what just happened is, where it created the vector, it put those 2 surfaces together with the mate constraint. So I'll click Apply. And you may come out here and move this around and see that these things don't look like they're connected together, but if I look at it from the right side view, those surfaces are mated together. And so I can move up and down. I can move left and right. So there's 2 degrees of freedom that I've gotten rid of with this component. Alright, so if we wanted to go ahead and finish this and constrain these together, then the other constraint we could use is flush. So flush is under the type mate if the solution is flush, and so I'll click the tops of both, and basically what it did is it just lined up the tops. I'll click Apply and Escape, and you can see that the tops are lined up, but I still have 1 transitional degree of freedom, and so I need to get rid of that. So I flush again. I can flush the other 2 sides, and now there are no degrees of freedom between these 2 objects. They're fully constrained together. Another type of constraint you can use is the tangent constraint. And all the tangent constraint does is it unites 2 curved surfaces. There are 2 solutions, an inside surface and an outside solution. And so there's 2 different ways to apply that tangent constraint. So I can go ahead and apply that, and you can see that the tangent constraint has put those shapes together. I'm going to actually go ahead and place another cylinder in there, and I'll show you the last constraint that I want to show you. This last one is the insert constraint, and so I'll go ahead, and this will be a very valuable one you'll use all the time in Inventor. Click Insert, and notice how it's finding the center of my cylinder, and it's selecting either the top or the bottom surface. If I select the top surface, and then I come over to my hole in my block, and it's selecting the top surface, the surface that's selected on the cylinder is going to line up with the surface that's selected on the hole. And so in this case, it's going to put those 2 surfaces together. If If I want the opposite of that to happen, I can click Aligned. And so it lines up those surfaces or it opposes those surfaces. So basically it's either mating them together or flushing them. So anytime you have a hole and you need to put some type of cylinder or fastener in it, use the insert constraint for that.